Hello everyone, myself Srivardhan Bhaviskar and this is SSJB's Mentora. Welcome to this series on DSP, Digital Signal Processing. Till now, we have discussed various parts of the Unit 1, like what is the basic definition of signal, what is the basic definition of system, and also seen various types of basic elementary signals. Now today, we will be continuing this further discussion of system. We have already seen the crisp definition of system, how it look likes. Let's see the formal definition of system and its various types of system. So system is an interconnection of blocks or unit which processes the input signal to give some desired output signal. Let's say I am having any input signal and having any system having some kind of impulse response. What is the response and how it works? We will see it afterwards. But to get the desired output from that system must be designed in a proper way, or it must be having some kind of specification which will give me the desired output. So this is the use of system by which we can process the input signal and get the desired results, desired output. So what are the types of systems? So the basic types of systems are the linear versus non-linear system. The first type. The second is the time variant versus time invariant systems. And third is the combination of first part and second part is the LTI systems. So let's start our today's discussion with what are the linear and non-linear systems. How do we configure that whether any specific system is linear or non-linear? So for a system to be linear, it must be having the some properties like the superposition principle and the homogeneity principle. Means I can say any specific system as linear only if it is having the superposition principle, means that system follows the superposition principle, and second the homogeneity principle. Now, what is the superposition principle? Superposition is nothing like the additivity. Like if I am having LHS and RHS, the addition, if I do the addition in the LHS, it must reflect the RHS. Means LHS and RHS must match after applying this property. So let's take an example. If my input signal is x of t, giving output as y of t, let's say x1 of t and y1 of t. X1 of t as input, giving y1 of t as output, and another one x2 of t as input, giving y2 of t as output. If I do the addition of x1 of t and x2 of t, x1 of t plus x2 of t, then it must give the output as y1 of t plus y2 of t. If this format is followed by any specific sequence, any specific signal, or sorry, not a signal, any specific system, then it's following the superposition principle. And what about homogeneity? Homogeneity is the multiplication property. It is followed by most of the cases, or most of the times it is followed. Like if I am having x of t and y of t as output, y of t as output. If I multiply it with a x of t, then it must be followed that a y of t as output. Okay, so if this property is followed, then it's a homogeneous, and if this part is followed, then it's a superposition principle. Okay, this is the superposition principle, and this part is the homogeneous. And when superposition and homogeneity both are followed by any specific system, then it's a linear system. Then only we can call the specific system as a linear system. And if it's not followed, then it's non-linear. So let's see some examples which will clear our thought that which system is linear or which system is non-linear. So let's start. If let's say I am having one y of n is equals to x of n. This is the simple system I will consider. By looking it, we can directly say that it's a linear system. But how to formulate? Because we need to write solution in university exams. So how we can write mathematically and prove it as linear? Let's see. Firstly, if I multiply, the solution is will start from here. If I multiply a y of n will be equal to a x of n, and it's very simple by definition that if I multiply the input, output will be multiplied by that. So it will always follow, these kind of equations will always follow homogeneity. Okay, this will always, and most of the cases we really don't need to check the homogeneity, because always most of the equations all trigger in the superposition principle only. So we'll mostly focus on the superposition principle. Now let's move to the superposition. Let's consider this equation. Let's split in the y1 of n is equals to x1 of n. This is the first part. Then y2 of n is equals to x2 of n. This is the second part. Now y dash of n is equals to y1 of n plus y2 of n, which will be obviously equal to x1 of n plus x2 of n, because y1 of n is equals to x1 of n, y2 of n is equals to x2 of n, and y dash is the one kind of information or the response we are taking, that y1 of n plus y2 of n will give this equation. We will number it as 1. What we have done, that considered the output first. Okay, y1 of n, we have considered the output and do the addition of output. We have done the addition of output. So this is the first part. Now second part, just we will analyze this equation, that it's given as y1 of n is equals to x of n. We will focus on this part. X of n is given. Now we have changed the output. Now we will change the input. Now x of n is considered. As we are saying the addition property, what we will do? The y double dash of n will be x1 of n plus x2 of n. So this is the y double dash of n. We have changed the input here and we have changed the output here. Because see, first we splitted the y of n and x of n equation in this format, the y1, x1, y2, x2, and do the addition. But here in y double dash of n, we simply added the signal. The x is written as x1 of n plus x2 of n. And as this will be numbered as 2, as the first equation and the second equation are looking similar, this is the this is the linear system. Now just hold on. You might be confused that how I directly write the x1 of n plus x2 of n. It's kind of confusing because here I have splitted and then write, but here I have directly written x1 of x1 plus x2 and said that linear, it's a linear system. So just hold on. We'll directly see the second example, which will clear all our doubts. Okay, let's see the second example. I hope first is clear, that first is the linear system because it has followed the homogeneity also, and this is the superposition also. Superposition is also followed. Okay. Now let's see the second example. I will simply write y of n is equals to x square of n. Just change is created as a square is done. First part will remain same. Homogeneity is followed by saying we can say it's homogeneous. For the superposition, for the superposition, we need to write the equation. Okay, for superposition, let's see. The first part, let's say again splitting y1 of n is equals to x1 square of n, y2 of n is equals to x2 square of n. Y dash of n will be equals to y1 of n plus y2 of n, which will be equals to x1 square of n plus x2 square of n. And this is the equation 1. Okay, I hope till now it's clear that we have again splitted y and x part into y1 x1, y1 of n is equals to x1 square of n, y2 of n is equals to x2 square of n, and by adding this part is come. This is the part 1. Now let's see the another part where we will just write the x of square. Okay, let's write the y of n is equals to x of n I will write, and whole bracket square will be written. I hope it's clear that this and this is similar, no changes. But what I am going to change that instead of x of n, because I want to prove the superposition, I have followed the y1 and y2 by adding this part is given for the linearity by changing x by x1 plus x2, I should get this part. Both equations must be similar, then only I can say this is the linear system. Similar part is done here that by doing y1 plus y2 I got the x1 plus x2, and here only the x of n only was here. Instead of x of n I place the x1 plus x2. So these both the equations are same, hence this system comes to be linear. But in this case, this will not happen because once I change x of n, till now of the previous example and this example, all the process is same. But here, once I change x of n with x1 of n plus x2 of n and its whole square, this equation will change. Its whole face will be changed because this is the kind of a plus b whole square kind of equation. And what is the expansion of a plus b whole square? That's x1 of square n plus x2 of square n plus 2 x1 of n into x2 of n. I hope it's clear that this is the expansion, and I will call this as y double dash of n, and this is the y dash of n, which is simply x1 square n plus x2 square n, but this is the y double dash of n where it's x1 square plus x2 square plus 2x1 x2, and this is equation 2. And as both equations are not equal, this is non-linear. This is non-linear system. This is non-linear system. Okay, I hope it's clear that from this example of square, and we can also create some results like wherever the square is at the RHS, the system most of the times becomes non-linear. But mostly for the university exams, we must write this kind of explanations. We can also some add multiple lines like homogeneity. Here we have used the shortcut because by just watching we can say it's a homogeneous, and but superposition is not followed, hence we have seen the non-linear system. Also here we can by watching we can say this is the linear also, and homogeneous and superposition is also followed, but we should write this kind of explanations and also add some kind lines like let's say the input is varied like this, output is varied like this is the equation 2 and 1, as both equations are same, hence this is linear system. And here as both equations are differ, this is the non-linear. Okay, now we have seen how the linear, which system is linear and which system is non-linear. Let's move to the next part. If I am having any system, how we can decide whether it's time variant or invariant? Okay, if you can guess, you will guess that by changing or by adding some delay. Yes, it's right, because by changing delays in input and output, we can infer that whether that specific system depends on time or not. Okay, we will discuss example. Just one theoretical part is that if I do add delay, okay, delays will be added. If delay is added in input and delay is added in output, both will create some expressions. Expression 1 and this is expression 2. If both the expressions are equal, if by adding delay in input and output, both the expressions are equal, means that system doesn't depend on time. This is the invariant. If it's equal, then the system is time invariant. Okay. And if both the expressions are not equal, if both the expressions, how? By adding delay in input and output, we'll get expression 1 and expression 2. And if both the expressions are equal, then it's a time invariant system. And if both the expressions are not equal, means delay, by adding delay expressions are also changing, then it's a time variant system. Then it's a time variant. And what is variant? Means that system depends on time. So let's see the example of that. If I am having, let's say I am having any kind of system, let's say, again similar example, y of n is equals to x of n. Y of n is equals to x of n. So first process we want to find whether it's time variant or invariant. What we will do, we'll just say, firstly we will see the delay in output, delay, output delay. And how we can add delay? By adding some constant k, let's say. So y dash of n will be x of n minus k. This is the delay in output. So this will become our equation 1. Now input delay. What is the input delay? What we will do? Input is what? The n. By changing this y double dash of n, we'll state that by changing the input y of n minus k, we can see the difference that y dash of n is, this is the output delay, as this is the output x of n minus k, this delay, and we are changing the input is n, and n is becomes n minus k. For that case, as see this, y of n is there, output is x of n. Y of, when n minus k will be there, obviously the x of n minus k will be here. Instead of n, we have just put the n minus k, and this is the equation 2. By saying this, x of n minus k, both the expressions, by doing the delay in output and input, both the expressions are same. Hence, this system is time invariant. This system is time invariant. Ignore the spelling and all stuff. Just focus on concepts. Like y dash of n is x of n minus k, y double dash of n is x of n minus k. Both the expressions are same. Followed by this process, which I have already mentioned multiple times, then this is the time invariant system. Now hold on, just we will again see similar kind of information. Will clear our doubt if any changes happens. Y of n, this is the another example, y of n is equals to x of minus n. The change is done, it's a time shifting. We have already seen the operations on signal. Y of n is equals to x of n, that's a simple example. Now we have just changed the y of n is equals to x of minus n. Similar process will be followed. First, the or right, we will write here. You also remember that first is the output delay. Okay, and for the output delay, our y dash of n will become x of minus n, as it is minus k. This is the equation 1. This is the output delay. And next is the input delay. Input delay. And for the input delay, we will just replace this n by n minus k. So this is the y double dash of n, which is equals to y of n minus k is equals to, now c, most important part is here, x of minus n. Simply write x, write minus. But just wait here. Don't write n as it is because we have changed the n by what? N minus k. So adding bracket n minus k will be here. I hope you will get a clue that this system will be time variant because both equations will differ. This was here, it was x of n minus k, but see here what it becomes, x of minus n plus k is here. X of minus n plus k is here. This is the equation 2. This is the equation 2. What happened? That output delay given us equation the x of minus n minus k, but by input delay x of minus n plus k. As both the equations are different, this system is time variant. This system is time variant. By changing the output and input delay, we get the two different expressions, and if both the expressions are not matching, they are slightly different, then this is the time variant. Means this system depends on time. Okay, I hope now the time variant and invariant is also clear. Now we have seen the linearity, which system is linear, non-linear, which system is time variant and invariant. Now the third comes is the LTI system. What are the LTI systems? LTI systems, LTI system is the combination of linear systems, linear systems plus time invariant. TI is the invariant, time invariant. So these are the LTI system, and the most important part, we will stop after this. The most important part, the output of the LTI system. Output of LTI system is convolution. Output of LTI system is convolution. All right, here that output of LTI system is convolution. And what is convolution? We have seen the LTI systems will give us convolution. But what is the formula of convolution? How mathematically we calculate the convolution? And what is the shortcut for convolution? And what is the exact concept and definition of convolution? We will see it in the next video. Thank you.